in example 2D, we again have the square root function. So I'm going to add in some key points on the square root function in blue, 1, 1, and then 4, 2. And so here is the parent function in blue, and I'll just highlight that. Here's the parent function in blue. And so what we're doing on this example is, again, like in the last example, we're doing a vertical translation up by 2. So each of these points, we're just going to move it up by 2. And if you want to see a more detailed example where we move the parent function up, you can look at the prior example, and we did it a little slower there, but same thing. Now we want to take that red function here, the square root of x plus 2, and we want to reflect it across the y-axis. And when we reflect across the y-axis, so here's our y-axis, so we're going to reflect it across this line. When we reflect across the y-axis, notice that we're going from the right side to the left side, or in some instances maybe from the left side to the right side, but we're affecting the x-coordinate. And so we're going to change the sign of those x-coordinates. So if you have the x-coordinates, you can really plot a reflection across the y-axis real specifically. So for instance, this point right here, we have 4, 4, and we know that the translated point then is we're going to multiply the x variable by -1, and we're going to get -4, 4. So we're going to get a new point right here. So this becomes -4, 4. And so then we can continue to do that for the other points. Maybe we should do the reflected one in green. And so if we took a look at this point here, which is 1, 3, would become -1, 3. So we get a point here, -1, 3. Notice that all that I'm doing is taking the red points and changing the sign of the x variable. So here's our rule. We're changing each point when we reflect across the y-axis. And so then if in green we wanted to sketch the reflected curve, here's the reflected curve in green. And before we leave this video, I think it's interesting to note that we know that what gets affected is the sign of the x-axis with a reflection. So if I wanted to modify this function to show that reflection, I would rewrite that new function as f of x is equal to, and then we would change the sign on the x variable, put a negative in front, plus 2. So that's what the function would look like here in green. So we could actually write the equation for that new reflected function.